Hello and welcome to you all. So I'm going to teach you the knowledge representation which comes under the unit 2 of course AI fundamentals. This course has been running in School of Computing Science and Engineering in Galgotia University. So first we try to understand what actually knowledge representation means. Knowledge representation are two words which actually have literal meanings. Knowledge means knowledge and representation that how that knowledge has been representation. But in terms or in a view of the AI agent. So an AI agent which expected to behave like an human and which fetch the information available to it and respond according to the information. So this knowledge representation actually implied to make an efficient AI agent so that it will respond in a very intelligent and specific manner. So what does representation mean? As I have told you that AI agents deals with knowledge. So this AI agents could be a robot or a machine which is expected to behave like a human, like an intelligent human. So knowledge is data. Knowledge could be facts, as I tell you. Fact could be beliefs and observed knowledge. Knowledge could be procedures like how to produce knowledge or how to use knowledge. Knowledge could be meaning, like relate and defining the knowledge. So the representation of a knowledge is in a right way is very crucial. This should be the early stage of development of artificial intelligence. The wrong choice can lead to project failure. So if we do not represent the knowledge in a correct way, this could lead to a full failure of the AI agent or the project. This is current active research area in the artificial intelligence domain. So how to choose a real representation or how to choose a right representation? For certain problem solving techniques, best representation is already known. We know that AI agents deals with the problem and that problem has to be solved by the AI agents. So for defining or for solving that particular problem, the best representation sometimes already known or sometimes a requirement of the technique. For example, so if we are using first order programming, so we will use first order logics, right? So or we will understand in later in the same lecture. Sometimes the solution of a problem which we are programming in a particular programming language, sometimes the representation of the knowledge is requirement of that particular programming language. So example of these things are, if we are going to prove first order theorem, we'll use first order logics. If we do inductive logic programming, we do logic programs. So if we use traditional neural network learning, we use neural networks. So the structure here is neural network and the process here is the neural network learning. Some of the general representation schemes suitable to many different and new AI applications. So some of the knowledge representation are so general that they can be applied to different AI application in commonly and in some of the new applications of AI also. So some of the common knowledge representations are logical representation, production rules, semantic networks. Under the semantic networks, we have conceptual graphs and frames. And we also have description logics, which is disappeared nowadays, but you can find it in traditional AI books. So what is logic? A language with concrete rules. So we understand that logics are straightforward statements, no ambiguity in the representation, maybe other errors. That means if a fact or if a knowledge is representation in one statements, this particular one statements is having one particular meaning. Allow unambiguous communication and processing. That means if one statement has been transferred from one agent to another agent, that means this particular statement has one particular meaning. That means this statement could not have any other meaning, which means this is an unambiguous communications. And this is very unlike to the natural language. We know that in natural language like human language, we have several meaning to one particular sentence, but in logical programming or logical reasoning we don't have that. There are many ways to translate between languages. A statement can be represented in different logics. So if we are having different types of logic, like first order logic, second order logic, or higher order logics, that can be represented in several logics and perhaps differently in same logic. So if you understand, if we write 2 plus 2 is equal to 4, we can also write 2 plus 1 is equal to 4. That means we are using the same logic, but the representation of the knowledge or the statement is particularly different. It also depends on the expressiveness of the logic. So how much the logic is expressive, this defines how much we can state in that particular language. And this particular logic things should not be confused with logical reasoning. Logics are language, reasoning is a process which use logics or which may not use logics. So, what are syntax and semantics? When we are trying to read, write, or understand a language, we must understand the syntax and the semantics. Syntax and the semantics are building parts of any language, or a program, or a logic. So, syntax defines the rules for constructing legal sentences in the logic. That means if I say, I am going, this is a legal sentence. But if I'm saying, going, I am, this is not legal sentence, right? Which symbols we can use, like which things we can use at a particular place, this is called syntax. So if you have been in a programming like C++, Java, Prolog, or Fortran, Python, etc., you must have faced syntax error. Syntax error, like if you're writing a particular statement, this should in a proper fashion. So how we are allowed to combine symbols? So if I write 2 plus 2 is equal to 4, we cannot write 2 plus is equal to 4, right? So this is syntax. What is semantics? How we interpret or read the sentences in logic. So the understanding of a sentence or giving it a particular meaning depends on semantics. So assign a meaning to each sentence. So for example, if we take the statements, all lecturers are 7 foot tall. So understand here, syntax and semantic, right syntax and semantic does not mean the sentence to be true. Sentence could be false, but it should not be wrong in a writing or reading manner. So if it is a valid sentence, so yeah, it is a valid sentence. All lecturers are 7 foot tall, which could be wrong. We know that I am 6 foot. That means all lecturers are not 7 foot tall. But it is a legal sentence. It is giving it is some meaning. So, and we understand the meaning. So if it is a validly written, and if it is providing a meaning, the meaning could be wrong. But if it is a providing a meaning, that means semantics is right. And if it is a valid sentence in terms of letters, punctuations, uh, and all the grammatical things, then it means the syntax is right. So this sentence happens to be false, which we understand, but this shows that the sentence is having syntax and the semantic in the right fashion. So yeah, logic is a good representation. Fairly easy to do translation when possible. Branches of mathematics devoted to it. So all over many branches of mathematics, like discrete mathematics, which is entirely written for deriving the logics, is devoted to logical representation. It enables us to do logical reasoning. So if we understand the logic, we can do the logical reasoning. And for that, tools and techniques came for free. It is basis of the programming language. As I say that if you have done any programming in a programming language, so you must have faced the syntax and semantics error. That means the logic is the basics of any programming language. For example, Prolog used logic programs, which is a subset of first order logics, and Lambda Prolog used higher order logics. So yeah. So for now, we would like to rewind what we understand. We understand what is knowledge representation, how knowledge could be stated, and what is the purpose of the knowledge representation. And one of the component of a knowledge representation is a logical representation. So we understand what's a logic, the idea of logic, and how that particular logic is used. So I'll give you 1 minute to understand and revive the concepts before going further. So yeah, if we understand the logical representation, we must move to the non-logical representation, which is, so what could be the non-logical representation? Non-logical representation could be production rules and semantic networks. Under the semantic networks, we have conceptual grams and frames, and we understood that the logic representation have restriction and can be hard to work with. So we understand that the logic programming or the logical representation has some of the criteria, like how much we can express in a particular statements. So these are the restrictions, and trust me, many AI researchers across the globe searching for a better representation. Production rules are also a textual thing. Only the networks, semantic networks, are graphical things. So we understand that the logical programs, we have the knowledge representation in a textual manner and the graphical manners also. So as we understood till now, the logical representation and non-logical representation, in the non-logical representation, we are going to understand the production rules and semantic networks. So what are production rules? So production rules are in pairs. That means the pair having two components. The first component is conditions. The second component is action. Like if this particular condition follows, the particular action should be take place by robo. So these production rules are read in form of if condition then action. These works on match result act cycle. The AI agent first match. That means agent checks if the rules condition holds or not. Then it resolves. If multiple production rules may fire at once, that means if I say if there is rain, I'll drink tea, or if there is evening, I'll drink coffee. So if there is rain in evening, what will I do? Right. So if multiple production rules may fire at once, there could be a conflict. Conflict means the countering of two actions at the same time. So agent must choose role from a set. So there should be a conflict resolution. Like if I say if there is rain, I'll drink tea. If there is evening, I'll drink coffee. So if there is a choice between tea and coffee, I'll drink tea. So there are two conditions following at the same time, like the rain in the evening. So there is conflict whether I should choose tea or coffee. But there is the conflict resolution. So if there is the choice of tea and coffee, I'll choose tea. So this is called conflict resolution. Act. So act means the final performance of the AI agent. So if so, rule fires, then the action is carried out by the AI agent. So it is expected that these rules are programmed in an AI robo so that it can perform at particular condition. So if I say like if there is sofa, then sit. So if there is robo and this rule is programmed in his CPU, then AI agent see if there is sofa and it will sit. So this is how AI agents programming has been done. These all production rules works in the working memory. Working memory, just like a human memory, the working memory states that means all the things happening at the live conditions, and we must choose and we can manipulate the things in the live condition. So rules can write knowledge to the working memory. Knowledge may match and fire other rules. So let's see the example of one production rule. So we have three production rules. So if at bus stops and bus arrives. So if suppose a robo is at bus stops and bus arrives, then the action should be get on the bus. There is second production rule which says if on bus and not paid and have oyster card, then action pay with oyster and add paid. The third production rule, the condition should be if on bus and paid and empty seat, then sit down. So you must have understand the logical or and operators. So and means if all the conditions are true, then only action taken place. And if or is there, that means any of the condition is true, then the action should take place. So condition and action must be clarified, defined, can easily be expressed in first order logic. So now understand. So if a robo is at bus stop, so if bus stops, if it is bus stops and bus not arrives, if bus does not arrive, then the action should be it will not get on the bus. If both the conditions, like if bus stops, if robo is on the bus stop, and if bus arrives, then only it can be on the bus, right? So if the robo is on the bus, first condition, and it is not paid the ticket, and have oyster card. If all three conditions are true, then only action should be pay with the oyster. So if robo is not on the bus and all the conditions are both all the other two conditions are true, then it will not pay with the oyster, right? If all three conditions are true, then only action should be pay with the oyster and add paid. So this if these three conditions are true, then the action would be pay with the oyster card and add paid. So now not paid condition is not there. So if now third production rule, if robo is on a bus and paid, like if second rules fired and empty seat, then only sit down. If robo is on the bus and paid, if there is not empty seat, like third condition is false, then it will not sit down. Right? If all three conditions are true, then only it is sit down. So this is how production rules are worked, and this is how production rules are programmed in an AI agent. Now comes to the graphical representation. As we understood the logical programming, the production rules, and now the graphical representation. We understood, we know that the visual memory of a human being is the fastest and most clear memory. Like if you heard something, you may have forget. If you read something, you could forget. But if you have seen something, it is very difficult to forget that thing. So visual memory is the strongest memory. So sometimes that's why we also say that the graphical representation which are knowledge which are semantic networks and frames are the strongest representation of knowledge. So as we know that humans draw diagram all the time. So these types of diagrams shows a causal relationship. So if you want to decorate your home, so before going decorated, there is conditions like required before. Before going to the decoration, you must buy paint and wallpaper first. Second, if you are married or you have partner, so you must check the color scheme with your partner. And this is also sometimes shows the relationship between ideas. So if you have gone through the discrete mathematics, the set if the operator has been added to the set, it becomes monoid. If we impose axioms to the monoid, it becomes group. And if we add operator on the group, it becomes ring. So this is how we use these diagrams to represent the knowledge. So we also know that graphs are very easy to store in a computer. And to be of any use, we must impose formalism. Formalism means if we want to use these two graphs at the same level, we must use the formality or the formalism on both the graphs. That means Arthur and Jim are brother, Ida and Mildred are sisters. That Arthur and Jim are brother, and it is having the same level like Ida and Mildred. That means Arthur, Jim, Ida, and Mildred are approximately of same age. Arthur is the friar of Brian. Arthur is the father of Brian. Ida is the mother of Jane. That means Brian and Jane is approximately of same age. Now Brian is the father of Jason. And Jane is also a Jason. So Jason is here the connecting link. So like Jason is having the father Brian and Jason is having the mother Jane. That means Brian and Jane are approximately of same age. So Brian's father, which is Jason's grandfather Arthur, and Jane's mother Ida, and Jason's grandmother, like Arthur and Ida, are the old people, are approximately same age. So Ida is having sister Mildred, and Arthur is having brother Jim. So we can impose a formality, and we understand that Jim and Mildred are of same age. And also, we know that Julia is the daughter of Mildred. That means Mildred is the mother of Julia. So the question is, how old is Julia? So if I ask you, like, who is the most closest person, like in terms of age, to Julia? You know that. So Mildred is approximated equal to the author. That means the author's son Brian could be of same age of Julia. So this is the formality. We represented, we imposed the formalism by replacing the mother and father relation with the general term parent. We know that Brian is the parent of Jason. Jane is the parent of Jason. That means Brian and Jane are approximately same age. Arthur is the parent of Brian. Ida is the parent of Jane. Arthur and Ida are approximately same age. Arthur and Jim are siblings. That means these are approximately same age. Ida and Mildred are siblings. That means these are of same age. So Mildred is the parent of Julia, and Arthur is the parent of Brian. Because the syntax is same, we can use that Julia is similar to the Brian's. So by imposing this formalism of replacing the mother and father relation with the parent, we understood now the syntax of both the graphs are same. So more about the semantic networks. Semantic representations are actually graphical representation or generally a graph. So a graph is denoted by the nodes and links. Link could indicate subset or members or relations. So the link are actually connecting lines between two nodes. Nodes are entity. Equivalent to the logical statements. So if I say 2 plus 2 is equal to 4, we can also write 2 plus 2 is equal to 4, where 4 is actually the link and 2 and 2 are entity. And we can say that 4 is a type of link to them. These are easier to understand the first order logic. Like if I write a complex statement in a logic, you may face a difficulty to understand that. But if I write down in a graph, you can easily understand that. Specialized semantic networks reasoning algorithm can be faster because it use less memory in the computer. Sentences with same meaning have the same graphs. That means the conceptual dependency theory by Shank has been followed. More about representation and logics. So AI wanted non-logical representation. That means the artificial intelligence we prefer non-logical. That means the graphical representation. Graphical representations are production rules and semantic networks. Under the semantic networks, we have conceptual graphs and frames. But all the things can be expressed in the first order logic. First order logics are the simplistic representation of the logic, although it is having the limitations. So if I need to write a complex statement in a first order logic, it may require a lot of memory. So these are best of the both the birds. Logical reading ensures representation well defined. Representations specialized for applications can make reasoning more easier and more intuitive. So in this lecture, we understand logical representation. What is the purpose of logical representation? The idea of knowledge representation, how the knowledge representations are used, what are the different types of knowledge, the logical representation, production rules, and semantic networks, and how we interpret those all the things. So go and check yourself and revive all the concepts. And if you do have any query, suggestions, or curiosity, you can reach me at my email ID anuj.bharti at galgotiasuniversity.edu.in. You can reach me at my mobile by following country code. The number is 77919555115. Thank you all.